Hello everyone, welcome to today's class. This is Teacher Simon taking you through Pure Mathematics 3 and this is paper 9709/35 for May, June 2025 and this is part 1 for questions 1 to 6. Question 1, solve the equation, this one here, give your answer correct to 3 significant figures. This is what we call an exponential equation. Now, there are 2 methods I'm going to use. Pick the one which is simpler for you, okay? Method 1, I'm going to use indices, okay? This one here, the powers are subtracted. That means this one comes from the division of powers of 3. You see that? So 3 power 4 out of 3 power 2x, then this one is equal to 5. Then times, this is 6 power x out of 6 power 1. You see that? Then from there, I need to put everything into one bracket. I need to put x on one side and then the rest of the numbers to another side. So I'm going to cross multiply here, and then I have 3 to the power of 4 times 6. Then I think I'll divide by 5 here. Then here I will have 3 to the power of 2x, then times 6 to the power of what? X. You see that? Now this one here, 3 to the power of 2x, it can be the same as 3 power x, then power 2. It can be the same as 3 power 2, then power x, okay? But I'm going to use 3 power 2, 3 power 2, power x. Why are we saying it is the same as 3 power x, then power 2, or this one here? It's because you can multiply 2 by x, and also x by 2, you get the same thing. You get it? Then times 6 to the power of x, and then here we have 3 power 4 is 81, times 6, then out of 5. What is this one here? 81 times 6, we get 486. 486 out of 5 is going to be equal to, now 3 squared is a 9, then times 6, and then we shall have power x here. Because in the indices, we have a power that a, power x, then times b, power x. This one is the same as a, b, then to the power of x, okay? They must be having the same power, such that you can multiply them or divide them, okay? Now, a mistake that is done by some students, like here, they can say 5 times that 6, so it is going to be 30. Then they write 30 power x, maybe power minus 1. This is very wrong, okay? This 5 here does not have the power x minus 1, so that you can multiply it with the 6. See that? Now let's proceed. Now from here, I can introduce logarithms on both sides. You can use natural logarithms or log base 10. So I can use natural log here, which is equal to the natural log of, isn't this one 54? Of x. Then this one will come down here. So we shall have x, the natural log of 54, then is equal to the natural log of 486 out of 5. So meaning x is going to be equal to the natural log of 486 out of 5. Then we divide by the natural log of 54. Then our answer becomes, we have natural log of 486 out of 5. Then down here, we have natural log of 54. The answer is 1.147, but to 3 significant figures, I'll write 1.15. 1.15 to 3 significant figures. That is one method. Then, alternatively, I can introduce logarithms straight away and then simplify. Alternatively, remember, we are having 3 3 to the power of 4 minus 2x, which is equal to 5 into 6 power minus x power 6, x minus 1. Now, we introduce the logarithms. Natural log of 3 to the power of 4 minus 2x. Then, which is equal to the natural log of 5 times 6 then power x minus 1. Using rules of logarithms, this one will come down here. So we shall have 4 minus 2x, then times the natural log of 3. And then here we shall have, it's a multiplication of these two, so it comes from addition of logarithms. So plus the natural log of 6, like that. And again, this one will come down here. Okay, I can first maybe leave this one here, like that, which is equal to natural log of 5, then plus x minus 1, natural log of 6. Now we open the brackets and then we make x the subject of the formula. Okay, so here we shall have 4 times the natural log of 3 minus 2x, also times the natural log of 3. Then this way we have natural log of 5, and then here we shall have x natural log of 6, then minus 1 times natural log of 6, it is minus natural log of 6. Put x on one side, I can bring it this other side, then these ones here, bring them this side. Okay, alright, so we are going to have 4 natural log of 3 minus natural log of 5, then plus natural log of 6. Then this one is going to be equal to x natural log of 6, then plus I can say x, then times 2 natural log of 3. Not so? This one here is the same as this. So I want to single out x. Now from here we shall have natural log of 3 power 4. Okay, because this one can come here. Then this is addition, so I will multiply with a 6 times 6. This is subtraction, then I will divide. This one is the same as this one, okay, because we had 81 here, which is 3 power what? 3 power 4. Okay, now how about this other side? X is common, I'm factorizing it out. Then I'll have natural log of 6, then plus this one here. This one can come up here. Okay, so we can have natural log of 6, then times 3 power 2. You get it? So that means our x here is going to be equal to the natural log of 486 out of 5, which we have here. Okay, then we divide by, this is 6 times 9, that is 54. Okay, that is 54, so natural log of 54. And this is exactly what we are having up here, so the answer has to be 1.15. As simple as that. Question 2 is coming from trigonometry. Solve the equation 3 cot theta minus 4 cosec squared theta plus 5 is equal to 0 for theta ranging from negative pi to pi. Now here, there is a connection between cosec and then cot. So we know that 1 plus cot squared theta is equal to this cosec. Okay, then we shall put a plus 5 here is equal to 0. So when you open the brackets, this is 3 cot theta minus 4 cot squared theta plus 5 is equal to 0. I can take everything this side that I have the coefficient of cot squared positive, so we shall have 4 cot squared theta, then minus 3 cot theta. This is minus 4 plus 5, it gives us a 1, right? Then when it crosses, it becomes a negative, which is equal to 0. So this is a quadratic equation, a quadratic equation in cot theta. I can use a calculator to see whether this one is factorizable, and then I solve. Mod, then equation is 5, then 3. Now we shall have 4, then negative 3, and then negative 1. So we get a 1, and then negative 1 over 4. So we shall say cot theta is equal to negative 1 over 4, and also cot theta is equal to 1. Now you need to show the attempt to solve this quadratic equation. A mark is given there. So tell us you give us the factor from which these roots come, okay? So we can cross multiply here, and then you get 4 cot of theta, and then bring this negative on this side, it becomes a positive, so plus 1. And then this one, just bring the one this side, then we get the factor as cot theta minus 1, which is equal to what? To 0. Now cot, we know that it is 1 over tan. So 1 over tan theta is equal to negative 1 over 4. When we cross multiply, this means that tan theta is going to be equal to negative 4. And also here 1 over tan theta is equal to 1. So meaning tan theta shall be equal to 1. Then we are going to look at these 4 quadrants. Okay. The A, S, T, and the C, 0. Here we have pi over 2. Then here we have pi. You see? Then here we are having 3 pi over 2 and then 2 pi. When we go anti-clockwise, the angles are positive. When we go clockwise, the angles are negative. So I can have theta here, and then also here. That means to move from here up to here, it will be equal to that 180, which is pi, then plus theta. Then if I project this one here, and also this other side, theta, that means to move from here up to here, we are going to have, what are we going to have? Pi, then minus theta, and then this one here is going to be 360. Because if this one is theta, now to move from here up to here, that will be 360, which is actually 2 pi here, then minus theta. Okay, then when I move like this, the angles are negative, so this implies that here we shall have negative pi over 2, then this one is negative pi, then the negative 3 pi over 2, and then this one will be the negative 2 pi when you come back here. Okay, now from here, theta is going to be equal to the arctan of negative 4. Now, what are we going to do here? When you take the arctan of this, it is going to give you a negative value, okay? In other words, we go to the quadrants where tan is negative. So tan is negative in the second quadrant, okay? And in the fourth what? Quadrant. Now, if we move anti-clockwise, we can find this angle, okay? Then, remember, it is here and also here. Now, when you take this anti-clockwise movement up to this fourth quadrant where tan is negative, the answer you're going to get is going to be way bigger than pi, or 180. So what do we therefore do? For that case, instead of moving like this, then we shall move like this. We move clockwise. Are we there? So theta here is going to be equal to, the calculator here has to be in radians. So we have arctan of negative 4. This one is giving us negative 1.32582. So I'll take this first one, negative 1, then 0.33. That is to 3 significant figures. The other answer is going to be when I move like this here, okay? So this will be 180, which is pi, then minus this arctan of 4, because arctan of negative 4 is the same as minus arctan of 4, okay? In other words, we get pi, then we subtract this one, we have, or we say minus, then the 1.3 and the rest of those figures. You see that? Then here, theta is going to be equal to the arctan of 1. Of course, this is 45. This is pi over 4. Tan is positive here and then here. You see that? Now, when you go the anti-clockwise movement up to here, the angle you are going to get here is going to be bigger than pi. So instead of going anti-clockwise, we shall then go clockwise, then up to here. Okay, because we have this allowance of negative movement. So I will say that this one will be now, for you to come up to here, it is going to be first of all pi here minus the theta, not so? So I'm just going to write it as pi here minus the theta I've gotten here, which is pi over 4. Okay, but in the negative direction, when I move like that, just put off the 45 and then the negative angle you get there. So this therefore implies that my answer here is going to be, we have, this is pi over 4. I can write them maybe in what? In ascending order. And this one is going to be what? This one is also negative, so I will have negative 3 pi over 4, not so? Yeah, actually, this is the smallest. Negative 3 pi over 4 is the one that comes from here. Okay, so negative 3 pi over 4. Then we have negative pi over 4. And, but this one is a positive one. Pardon me here. Pi over 4. Then the next one is going to be this negative. There is negative 1.33. Negative 1.33. Let me take this one here. Then I have negative 1.33. And then lastly, what we get here. Pi minus then the arctan of 4, that is 1.82, 1.82, and that is that. These other ones, I'm writing them to 3 significant what? Figures. Question 3 is coming from complex numbers. The complex numbers s and t are given by this equation here, and then this one, express s over t in the form r e to the power of I theta, where theta ranges from negative pi to pi and r is greater than 1, 0. Okay, so we have s out of t, which is going to be, I can convert. Okay, this one is in the polar form, this one is in the exponential form. I need to put them in one form, then I can solve them. But since they said we express it in this exponential form, then I have to turn this one there. Now we know that e to the power of I theta is equal to cosine of theta plus I sine of theta. Are we there? So this simply implies that if you have 5, this s here, which is equal to 5, then cosine of 0.25 plus I, then sine of 0.25, then this one here shall be 5, then e to the power of, we shall have I here, and then the 0.25 I. You see? Now s over t will therefore be equal to 5, then e to the power of 0.25 I. Then we divide by 6, e to the power of 3i. So using rules of indices, of course, 5 will divide by the 6 here, and then e, we shall get 0.25, then minus 3. Okay, we subtract the powers. So this one becomes 5 out of 6. then e to the power of, this will be negative 2.75 I. Okay, that is our s out of what? T. As simple as that. All right, then next, they are saying that in an Argand diagram with origin O, the points A and B represent the complex numbers S and S over T respectively. By considering the line segments OA and OB or otherwise, state the two geometric effects of dividing a complex number by this one here, the 6e to the power of 3I. Now, we are looking at point B, okay, which represents S over T, okay, S over T. And then we also have A, which represents S. Remember, S is equal to 5. S is this one here, 5e to the power of 0.25i. Then, okay, so that is that. Then we also have S over T from here, which is equal to this one here. So this one, we see that it is point A, and then this one is what? Point B. Now, after dividing, they are saying by considering this, state the two geometric effects. We look at transformations. So what has happened? Okay. Now, when you look at this one here, this one is 5, but this is 5 over 6. That means this one has been multiplied by 1 over 6, not so. From here, it is like I multiplied this one by 1 over 6, such that the 5 here now becomes the 5 over what? Over 6. So in that case, I will have enlargement, okay? Enlargement by scale factor. Enlargement by scale factor 1 over 6. Okay, you remember when we have y is equal to f of ax, actually it is a f of x, okay, in pure mathematics 1, then this is an enlargement. We actually say stretch by factor a parallel to y-axis, okay. So this one I can say it is an enlargement because we have just multiplied through by something here, and the center is actually the origin, yeah? So enlargement by scale factor 1 over 6, okay. You can write that, or you can say stretch by factor 1 over 6, then parallel to y-axis. So this time around I will say imaginary axis, okay, parallel to imaginary axis. Then after that, but it is just the length here that is changing, so we can just take enlargement. All right, then the other one can be now the angle, okay. This angle here, e to the power of, this angle here, e to the power of negative 2.75, okay, is coming from e to the power of 0.25, then minus what? 3. You get it? Minus 3i. So that means if this one is a minus, you are taking off the 3, and I told you that when you are moving these angles, let me take you back to trigonometry here. When you are moving angles clockwise, they are what? Negative. Now, this one is being rotated, okay? I can actually see here rotation, okay, through 3 radians, because the angle reduces by what? By 3. So they are moving clockwise. You get that? By 3 radians. By 3 radians clockwise. Because it is in clockwise movement where we are getting what? The negative angles. As simple as that. Question 4 is coming from differentiation. Find the exact coordinates of the stationary point of the curve with this equation here for x greater than 1, 0. And we can see that this one is a product of 2 functions. So therefore, to differentiate this one here, we shall use what? Product rule. So using product rule, this simply implies that our dy dx shall be equal to, keep this one constant, differentiate the natural log. Okay, then after that, keep the natural log here constant, and then differentiate the 3x power 3. And after that, we shall equate to 0 because they said what? Stationary points. Now, when we differentiate natural log of a function, we get the function, we differentiate it, then we divide by that same function. Okay, now here we shall have, let me write this one here also for stationary points, dy dx is equal to 0. Now we shall have a 3 here, x power 3 times, we shall differentiate this one, it will give us 4x cubed, then we shall divide by that x power 4. What I've done here is what is here, okay? Then plus, this is natural log of x power 4. Then when we differentiate here, we shall get 9, then x power 2, not so? Because this one multiplies with that, and then you reduce the power by 1. Then we shall equate to what? To 0. Then after that, I can try to simplify here. This is x power 6, and then x power 6. When you divide by x power 4, 6 minus 4, that is a 2. So we shall have 12, then x power 2. Then here plus 9x squared, then natural log of x power 4. It is better to always write this other function first before the natural log, because people can usually mess with this. Someone can multiply this 9x squared with the x power 4. So this one is equal to 0. Now what is common here? 3x squared, not so? That means here I'm remaining with a 4. And then here we shall have 3, then natural log of x to the power of 4, which is equal to 0. Now that means I can equate this one to 0, and then I get x is equal to 0, right? Then another one, I can get this one here, plus 3, natural log of x is equal to 4 is equal to 0. Now, using rules of logarithms, I can have this one come back here. In other words, I can have that 12, the natural log of x, and then I can take this on this other side, it becomes a negative, meaning natural log of x is going to be negative 4 out of 12, which is a third. So for me to get x here, then it will be e to the power of negative 1, a third. Remember, this one is the same as log e power x, okay, which is equal to negative a third. And then we say e power this, then is equal to that. You see that? So that is that. Then, after getting this value here, what will be the value of y? Remember, they said that x here is greater than 0. So we don't need this one when x is equal to 0. This is the value of x we are going to take. Then we can substitute it here to get the value of y. So this will be 3, then times e to the power of negative a third, but it is cubed. And then what else? We have the natural log of x here, then power 4. So what do we get here? First of all, this one will be e to the power of negative 1, because these ones will multiply, not so? Then times, this will be natural log of e to the power of negative 4 over 3. Then this one can come down here, and then natural log of e is a 1. So meaning we shall have 3 e to the power of negative 1, then times negative 4 over 3. And the answer becomes 4, negative 4 e power negative 1. So I can write my coordinates as e to the power of negative a third, then negative 4 e to the power of negative 1. You can even write this one as the cube root, 1 over the cube root of e. Then this one as negative 4 over e. You see? So that's all the same answer. That is that. Question 5 is coming from complex numbers again. The diagram shows the locus of points representing the complex numbers z satisfying this modulus equation. Part A, find a point on this locus, then determine the maximum and the minimum possible values of z. Now this one here represents a circle, okay? When you see that you have the modular signs on one side, that will be a circle, and this one is the radius. Now we have z, then plus 5 minus 4i. I have already said that you create a negative here. So we have z, then minus what? But you shouldn't change the meaning here. Since 5 is positive here, that means inside here it will be a minus. And then what was minus becomes a plus, right? Something like that. So we have a circle of radius 3 and center. What is the center? Negative 5, 4. Okay? And here we are looking at the circumference of a circle. All the points that are 3 units from the center, that is what we call the circle here. So we are taking what is on the circumference of the circle, but suppose we had less than, that means we would consider inside the circle, and the circumference of the circle here would have been dotted, you get it? Because no point on it is considered. All right, now this is the one we are having there. Then after that, of course, we are going to look for the center. They said find the points on this locus. You see? Then, not find, pardon me there. For the points on this locus, determine the maximum and the minimum possible values of z. So I'm going to come to this circle here, and then this one is going to be the what? The center. Then we can connect this one here, and then they're saying points on this locus. So even from the center here, and then I drew to this one here, that one will give us what we call a tangent. Okay, like that. Remember they said what? The modulus of z. So that means the length. Now I'm going to have the maximum and the minimum. Now from the center here, and then you draw to this circle. We can also draw up to there. We draw lines all through, connecting to the what? To these centers here, to the circumference of the circle. So this simply implies that the longest, I think, will be from the center here, from the 0, 0, it passes through the center of that circle, like that, but then it continues up to this other end here. Okay, it passes through the center to the circumference. You see that? Then we also have this one that can connect here. Okay, then we also have this other one here. So the maximum, we are going to look at this one in the what? This one going through the center. Now let me make these lines, all of them dotted, because I've just drawn them. They were not part of the diagram. Now after that, we are going to use triangles here. Okay, so the radius here, remember it is 3 units, even here it is 3. In circle theorems, you know that the gradient between the tangent and the radius is always equal to, the angle between the tangent and the radius is always equal to 90 degrees. You see that? Well, this one is 3 units, 3 units here. Now, this is a tangent because it is meeting the circle on the one point here. You see that? All right. Now, we have a triangle here. There is what we have to do here. If the center here is 3 units, that means from here up to here is 3. That means from here up to here is what? 1 unit. Are we there? This one here is 1 unit. Okay. And what's the center? The center is negative 5, 4. Negative 5, 4. Yeah, that is why this one is a 3 and then a 1 to give us a what? A 4. Then this one will be 5 units from here up to there. So negative 5 and then 4. That is the center. So that means here I have 5 units and then here I have 4 units. So I can get the hypotenuse here to get this one. So when I get the length of this one here, and then I add on a 3, I will be in a position to get the maximum possible value of the modulus of z. You see that? All right. Now here we shall have 5 squared plus 4 squared. 5 squared is 25, then plus 16, that is 41. Okay. Then we shall have the minimum for z. It is actually going to be this part here, this one, from the center. Which one is the minimum when it is passing through here? You see that? Now, I actually don't need this line here. We can even take it off because it won't give us, we don't need it anyway. So the minimum is going to be from here up to here. We have gotten it as root of what? 41. Not so. Then subtract off this 3 here, then you will get this distance here. So minus 3. And then the maximum here is going to be, if you check here, it has to be what we have gotten here, then plus the 3. As simple as that. So root of 41, then plus 3. Those are our answers. Okay. Then we are saying part B, for the points on this locus, determine the minimum possible value of the argument of z minimum. Now, for the minimum possible value, of course, from here up to here, remember you are measuring the argument from the positive real axis. So we measure from here, then to here. I think that will be the minimum, because as you go forth, it becomes bigger and bigger. Not so. This, in fact, if they asked for the maximum, then it would be this other line here, which I put off. You see that? Now, therefore, I'm going to, now first of all, from here, if you can connect here, a point here, what is this one going to be? Remember, we have many things here. So for the minimum, we shall have to find this angle here. Okay. In fact, let me just draw something small here. We have these triangles. We have these triangles here. The first one down here. Then there is this one connecting now to the center of the circle. I mean the circumference of the circle. And this one is 90 degrees. Why is it 90 degrees? Because this one is the radius. Remember? And this one here, what I'm talking about is this one here. So there is this triangle, but there is also this one here. Okay. So this other one here. Okay. I think I have to repeat this one here. It will have to be, there is this one here, and then connecting here, the center. Then we have this imaginary axis here. Okay, the imaginary axis is there, and then we have the radius here, then coming there, and then this one will connect to that. All right. Now, I have this one as root of 41. Root of 41. I have this as 5 units, then this one as 4 units. Okay, let's check back the diagram on this one here. You get that? Then this one here, root of 41, this is 3. That means we don't even need the length there. We just need the angle. Okay, now suppose I take this one to be maybe alpha, then this one to be theta. You see that? And then what else shall we have? Then this one will be maybe gamma. Okay. Now I can, maybe using this and this, I can get the alpha. Then using this one is 3, the radius, also from here. Now using the radius, which is 3, and this one here, okay, because the 90 is here. So this is opposite of hypotenuse. Then I can also get what? Theta. Then remember, my mandate is to find this alpha here. Then I add it on the 90. You get that? So our argument is going to be from here to there. That is our argument of Z, the minimum. Now, let's begin. We need to find this length here. Okay? If we can find that length there, because this one will be 90. Do we really need it? I don't think we need it. We don't need it. Let's just find this. If we find these two, we subtract from a 90, then we shall get this alpha, right? Okay, now let's go. I'm going to have tan. So using SOHCAHTOA, tan of alpha is going to be equal to 4 over 5. So meaning alpha is going to be the arctan of what? 4 over 5. Okay, then next, I can have sine of theta, which is going to be equal to opposite, because relative to this angle, this will be the opposite. Then the side which is adjacent is the one that is perpendicular to the adjacent, okay, to the opposite, which is this one. So this one has to be the hypotenuse. So 3 out of root of what? 41. So meaning theta is going to be the arcsine of 3 out of root of 41. Then that means our gamma is going to be equal to 90, which is pi over 2. Yes, I can use radians or I can use degrees, okay? Any you want. So it will be pi over 2, then minus, these two here. So minus the arctan of 4 out of 5 minus the arcsine of 3 out of root of 41. And then I can get that answer there. Okay. When I get that answer there, I'm supposed to add on a 90. Okay. I'm supposed to add on a what? A 90 so that I get the argument. Okay. Now, I just say 180 minus these two. It is the same. You get it? So, in fact, I'm going to let this one be what? 180 minus those angles. No. By the way, this one is that. So the minimum argument of z then is going to be equal to what we have gotten here, then plus the 90. So pi over 2, then plus this one here, plus the alpha. Okay. So it is like 180, which is pi, then minus the whole of this. You get that? Okay, now to 3 significant figures, this one becomes, the calculator has to be in radians. Okay, or if you use degrees, no problem. Then we can have shift pi here, then minus, we have the arctan of 4 out of 5. Then we also have the arcsine of 3 out of root of 41. We have 1.98 radians. Okay. If it is in degrees, what will it be? I will change the mode of the calculator. So shift, then mode, it has to be in degrees. Then where there is pi, I will put 180. Okay. And then we get 113.4. 113.4. That is if it is in degrees. Okay. Question 6, we are given these parametric equations and they're saying show that dy dx can be written in terms of cosec 3t. Okay, where a is a constant to be found. Now, if x is equal to 2, take this one up, it will become sec. So 2 sec 3t. And you know that when you differentiate sec, you get sectan. You check in the list of formulae, okay? Sectan. So we shall have 2, then times sec, okay? Then tan of that angle. But then you also have to enter and you differentiate the angle, you will get a 3, then you multiply it all through using chain rule. You see that? So this implies that here we shall have 6, then sec 3t, tan 3t. And then when I come to y, which is equal to tan, y is equal to tan 3t, then dy dt shall be equal to sec squared. When you differentiate tan, you get sec squared. But then enter inside and differentiate here. So you multiply 3, that will be a 3. You get that? Now using chain rule, dy dx is going to be equal to dy dt, then times dt dx. So this is using what? Chain rule. And then we can substitute. So dy dt is 3 sec squared 3t, then times dt dx is 1 over dx dt. So it is 1 over 6 sec 3t, then tan 3t. dt dx is equal to 1 over dx dt. Okay. Now, 1 sec 3t here will cancel with 1 here. Okay. So that means we are getting sec 3t, then divide by, of course, 3 goes into 6 2 times. So we shall have a 2 here, then tan 3t. Okay, now this is the same as they said we write it in terms of cosec. That is 1 over sine. So sec is 1 over cosine. Then times, this one is over 1. So the reciprocal of this one is going to be, I can actually leave the 2 here, okay, like that. Then times 1 over tan is the same as cos over what? Cos over sine. Then this one will go, and then we shall have 1 over 2, then sine 3t. 1 over sine is cosec. So cosec 3t. Now that is our answer here. So the A is a half, and then a cosec. You see that? Then part B, find an equation of the normal to the curve at the point where t is equal to pi over 12. Give your answer in the form y is equal to mx plus c, where m and c are exact. Now you know that when you are to find the equation of a straight line, you need at least one point through which a line passes and also the gradient. You see? So for t, we need a point through which the line passes. For t, which is equal to pi over 12. Okay? What is x? So x is going to be equal to, remember when we check, it is 2 sec 3t. 2 sec is 1 over cos, okay? Sec 3t. Then y is going to be, it is tan 3t. Tan, then 3, t is pi over 12. So this one here is going to be pi over 4, which is a 1 when you get its tan. And then here we have again pi over 4. So this one will be root 2 over 2. So this one will somersault, goes here, or we shall have 1 over root 2. Then it somersaults and goes there. So that means the whole answer becomes 2 root 2. 2 root of 2. You see that? Then from there, what will be the gradient? dy dx, the gradient of the tangent. Because remember, dy dx is gradient of the tangent. So it is going to be 1 over 2. Remember, it is cosec 3t, which is 1 over sine. So it is sine, then 3 pi over 2. 3 pi over 12. Pardon me here. Sine of 45 is 1 over root 2. Okay, so if we have 1 over 2, then times, let's say root 2 over 2. Because 1 over root 2 is the same as root 2 over 2. So this one will cancel that. And then you get 1 over root of 2. Then gradient of normal is going to be equal to negative 1 over gradient of the tangent. That means this one comes out as negative root of 2. You see that? So we have the gradient, and we also have coordinates of the point through which a line passes. Usually I have always drawn this and then said if this is, let's say, the curve meeting this line at one point, then this one becomes the tangent. This is the curve, and then there is that line which is perpendicular. Okay, that line which is perpendicular to the tangent, it is what we call the what? The normal. Now we have this point which is 2 root 2, then 1. Now using y minus y1, which is equal to m into x minus x1, our point is 2 root 2, then 1. This is the y1, this is the x1. So we shall have y minus 1, which is equal to m, is negative root 2, then x minus 2 root of 2. I can take the one this other side. When I open the brackets here, we shall have negative root of 2 of x, then plus root 2 times root 2, that one gives us a 2, then times the 2, that one gives us a 4. Okay, then when one crosses, it is a plus, not so? So meaning the equation of the normal is going to be negative y is equal to negative root of 2, then x, and then plus what? 5. They said that m and x have to be, m and c have to be exact. So our m here is this one, the root 2, which is exact. Also 5 here is exact. So that is that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.